Shishkant over here. This is a quick demonstration video of the constraint motions involved in the project that I aptly call as Amngel. Angular momentum commutation and gyroscopic precision enabled long zebra. It is kind of a sci-fi super weapon, just like a lightsaber. So just let me walk you through the constraint motions involved in this, so that you can clearly grasp the idea of what all is going to happen in this project. So what we have here is a simple threaded rod, which I'm going to call it a three rod, and another one is this motor. And after that, this is a hollow motor, whose I'm going to show the company's name and all in my background for this, and it is really interesting. And thanks, kudos to the company for providing really detailed data sheet and even 3D models of those motors. So it was actually the seed that helped me, to make this a little bit easily. And otherwise, more modeling motor and all that would have been really hard, and I was unable to decide the dimensions also initially. What would be the realistic dynamic dimensions of this project? So it helped me to actually determine the realistic dimensions for this project. I just built around it actually. It really thanks to the company which provides an STL file to the components. They are goats. And what this study rod is going to help us do is, as you can see, let me see, set it as active. As you can see, this threaded rod is going to interact with this. This is a component which would lie in between the uh, hollow motor, and the rod, which is also threaded. Because it is threaded and the rod is also threaded. When the rod rotates, as it can't rotate, it would actually move forward or be backward. Let me animate and show you what do I mean. And animations are going to be really choppy because of I actually shouldn't have modeled the threads into it. Because of that, it is struggling a lot, I guess. Let me set it as active, and let me animate this motion link, joint relationships. As you can see, as this rod rotates, it is going to move forward or backwards. And uh, and the overall impact on the that is on this hollow motor is something like this. As you can see, it is going to move forward and backwards, and this threads are going to rotate forward and backwards. What all it is going to do is actually move the mass of the flywheel forward and backward, and this would give us some control over the precision and notation involved in this device. So it is actually not totally random, but something that we can control. So let me just stop it. After this, you can see this is just the mirror of this. This is actually the way from where the power and all cabling and that all we are going to do. And the power delivery to the hollow motor would be something like the using brushes. The brushes we used in brush VDC motors. They are dynamic contact points. Moving contact points for transferring electricity. And just let me. As you can see, these sleeves have some surfaces which can be you know laid with conductors, and this as you can see, this prong like the things, they are going to latch on to them, and something like spring like mechanism we can keep to actually deliver power dynamically, no matter where this hollow motor is going to stand. And that, I think, it is really complicated solution. I think, is it possible or not, as it is going to face some forces and that all, stabilizing it and all that would be quite a big challenge, I guess. And you would might ask, why are you having two flywheels? That would just complicate it. But actually, having two flywheels is really important, because while during the initial spin of the motors, there would be a lot of torque generated in the system, and that torque is going to destabilize the systems. As the torque is going to generate, this torque is going to be passed on to the this housing and all, and that would not be a good thing, I say. And because of this torque, having a system stable after after spinning the gyroscope would be a really huge torque. So to counteract that, what we are going to do, have two counter rotating flywheels which would cancel each other's torque. And what it is going to do is uh, keep the system stable during the startup. And then we can dynamically adjust the center of mass of the system. And the pivot would lie around here. And having dynamic center of mass helps us to take the system from still to moving. And the system would not just tilt in a way, it would actually also act in a just tilt like this. Normal system would just tilt like this. If you move the center of mass from here to here, it was just going to tilt because it has two counter rotating motors, and they are going to induce some gyroscopic precision and some angular nutation, and Coriolis forces are also going to come to play. The system is going to behave really unexpectedly, and I can't, you can use this finger rules and all to determine its just general direction of motors, but it is really rudimentary. Actually controlling it would require collecting a lot of data and rewriting the equations of kinematics. And is it possible or is it impossible? I am curious about. That is the only reason I am just liberating it from my thoughts, from my brain. I want some smarter people to work on this to conquer this. I believe that is truest form of engineering. Controlling and harnessing something out of control is the true engineering, I guess. We build dams because we can control out of control floods. We build roads because we don't want puddles in rainy season, dust in summer season, and all. Controlling something truly out of control is engineering, I guess. And I think this would be the truly most adventurous engineering endeavor because I haven't seen any research papers and all where gyroscopics are not just used to make observations but to control the system. And you would might say satellites use gyroscopes all the time. And by I have also seen some bikes which stay stable using some kind of rotating system. But I don't think they are actually using gyroscopic precision. They are just using gyroscopic precision. Sorry, they are just using the torque induced by spinning something to prevent something from falling or to set something in motion or change the orientation of something. So, as as far as I studied, gyroscopics are used in making truly a passive observation of systems, like in initial inertial guidance system and all. This would be a totally new perspective on gyroscopes, a perspective which looks to use their precision not to make observations but to manipulate a system. And that's something really big. And I am not going to put any copyrights and all on it. I am just too drained trying to think about it, trying to figure it out by myself. I don't have capital to manifest it. I don't have the mind which could comprehend to control it. A lot of data and training is going to need. So I want some people, much smarter people to work on this. I want this to be actually used in real world. Somebody might have done it. I don't know. As far as I know, this is something truly unique, and I just can't live by keeping it in my mind. It is actually really unhealthy. I can't sleep at night peacefully. I try to understand it and all. I let this. I would rather see better people, people smarter than me handle it, than go crazy trying to understand it, trying to materialize it. So, thank you. Bye.